Rapid-MLX run powerful AI models locally on your Mac faster than anything else. Rapid-MLX is a local inference server for Apple Silicon. It runs large language and vision models right on your Mac, with no cloud and no API bills. It speaks the OpenAI protocol, so tools like Cursor and Claude Code just work. And it is built on Apple's MLX framework, tuned for Apple Silicon. So why is it fast? Apple's unified memory lets the GPU read model weights with zero copying between chips. Every forward pass runs on the Metal GPU by default. And with enough memory, a single Mac can hold frontier models that other laptops simply cannot. On real benchmarks, Rapid-MLX is 2 to 4 times faster than Ollama. GPT-OSS 20B runs at 119 tokens per second, about 2.3 times Ollama's speed. Qwen and Gemma models lead by 1.7 to 2.4 times on the same hardware, and against MLXLM serve on identical weights, it is still 1.2 to 1.5 times faster. Here is how a single request flows through the engine. Your prompt is tokenized, then checked against the prefix cache to skip work already done. It runs prefill, then decodes one token at a time on the GPU. Finally, the tokens are detokenized and streamed back to you as text, all driven by a continuous batching scheduler. Using it as a one-liner. A single serve command starts an OpenAI-compatible endpoint on localhost. It works with Cursor, Claude Code, Aider, and any OpenAI SDK, and it even speaks the Anthropic Messages API for native clients. The scheduler is where throughput comes from. Instead of running requests one by one, it batches many of them together on the GPU. As soon as one request finishes, a new one slots into its place, so the GPU never sits idle. This is what lets Rapid-MLX serve several clients at full speed. To go even faster, Rapid-MLX is smart about memory. A prefix cache reuses shared context across requests instantly, so common prompts are nearly free. Paged attention packs the key value cache like virtual memory, avoiding waste, and optional quantization shrinks that cache to fit much longer contexts. It also ships advanced speculative decoding. A small drafter model guesses several tokens ahead. Then the big model verifies them all in a single pass, accepting the correct ones. Techniques like deflash and suffix decoding can nearly double throughput on the right models. To show it off, let's look at two very different models running locally, one built for tools and one that can see. First, GPT-OSS 20B. It is a 20 billion parameter mixture of experts model. It is Harmony native, which gives it rock-solid tool calling, and it sustains about 115 tokens per second on an M4 Max. Second, Gemma 412B. It is a 12 billion vision language model that can actually see images. It reads diagrams, performs OCR, and interprets charts, and it also calls tools, all in 4-bit, on the very same Mac. Both models can call your code. When the model needs live data, it emits a tool call. Rapid-MLX runs your function, feeds the result back, and the model continues, looping until it has a final answer. Here it checks the weather and runs a calculation, then replies. Gemma's vision is genuinely useful. It can describe a diagram and explain how data flows through it. It can transcribe text from an image using OCR, and it can read a bar chart and tell you which quarter is highest. We measured it all on an M4 Max. GPT-OSS 20B sustained 115 tokens per second for reasoning and code. Gemma 4's vision ran between 30 and 37 tokens per second, end to end, and every bit of it ran on the GPU inside 64 gigabytes of unified memory. Rapid-MLX has a few modes. The serve command opens an OpenAI server on port 8000. It streams tokens over standard server-sent events, and it handles many concurrent clients at once. Prefer the terminal? The chat command drops you into an instant, REPL. Slash commands let you switch models or toggle thinking on the fly. It is perfect for a quick question with zero setup at all. You can also go public. The share command tunnels your local model to a public HTTPS link. Bearer auth and rate limits are wired in by default. and closing the terminal tears the connection down instantly. To tie it together, there is a live demo. A Gradio app spawns both model servers for you automatically. It has streaming chat, image upload, and tool calling, all in tabs. And a capabilities tab benchmarks tokens per second live, right in the browser. Getting started takes seconds. Install it with a single u.v command. Serve any model to get an OpenAI endpoint on port 8000. Or simply type chat to start talking to a model right away. So why does this matter? It is private by default. Your data never leaves the machine. It costs nothing once the weights are downloaded, and it puts frontier-class models, running fast, on hardware you already own.
If you like this video, please subscribe and share. Thank you.